2004, question 1a. The ball is thrown vertically upwards with initial velocity 20. So let's say the ball is going up like this. U is equal to 20. And 1 second later, another ball is thrown from the same point, call this the point, with a velocity of u. And the balls collide after a further 2 seconds. So you have the first one fired, then a gap of 1 second, and then another gap of 2 seconds. So when t is equal to 3, they collide. So let's have a look at what's going on with the information that we have. So let's use displacement. We have u being 20, t being 3, and we can find how far this particle here is. Gravity is 9.8, so minus 4.9 by t squared, 3 squared. So the distance traveled, we'll call this one a, say, let's say. The distance traveled by a in this 3 second period is 60, minus 9 5 is 45, minus 0.9, 44.1. So the distance traveled by a, or the displacement of a, we'll see where the distance is now in a minute. 60 minus 44.1 is 15.9 meters. So they collide at this point. Now this will be a quadratic in terms of time and distance. So the other one we have to show has an initial velocity of 17.75. So let's call this one b. So the displacement of b is 15.9. That's when they collide. So 15.9 is equal to ut, u, and there was a 1 second gap here, so 2 seconds in the air for b, times 2, minus 4.9 by 2 squared. So on the right we'll have 2u minus 44.9, so 19.6 is equal to 15.9, giving 2u to be 34 and 1.5, 35.5. So u is 17, as we're asked, 17.75 meters per second. And then we're asked to find the distance. We're looking at displacement here, the distance traveled by each ball before the collision. So let's look at a here. We know when it gets to the top here, before it starts going back down, this is when the velocity becomes 0. So if we're dealing with displacement and distance and velocity, we use v squared is equal to u squared plus 2as. So how far up velocity will be 0 does a particle go when it's fired at 20 meters per second, and gravity taking effect will be this equation. So s is going to be the initial velocity squared divided by 19.6. So this is the max height, and then it's going to be on the way back down. It's going to travel a little bit more distance till it gets to the point at 15.9 meters. So let's just put this into a calculator. It's giving me 20.4 meters. So it has gone up to here at 20.4, and then it's on its way back down. Let's just write it like this, and it ends up at 15.9. So this distance in here is 20.4 minus the 15.9 it would still have to go to get to the ground. So that's 4.5. So we add the 4.5 on, we'll get the distance traveled by a to be 24.9 meters. I think it's to the nearest meter here. To the nearest meter will be 25 meters for this one. Similarly with b, v squared 0 is going to be equal to that initial velocity squared up above, 7.5, plus twice. Now you could just write it like this straight away if you wanted. You can see that's where it's going, minus 9.8 by s. So max height of b, s is equal to, left out the squared, 17.75 squared divided by 19.6. So this max h for b is equal to 16.07, and then b goes up to 16.07, and then starts traveling back down, so the other one catches up with it on the way back down. This is 15.9 where they collide, so we have this distance 16.07 minus 15.9, which is just a very small number of 0.17, 0.17. So 16.07 and 0.17 gives 16.24 meters. Correct to the nearest meter, 16 meters for B. And for those that get to the end, 2022, this is my prediction.